Part A, question number 1. Calculate the amount at the end of the investment period for P without 22,225 and 7 cents. Centrally for T 0.102. Next for N without 4 and lastly T is 15. Now for the I, we using T over M, so 0.102 over 4 and without 0.0255. Next for the N, we using MT, so 4 multiplied to 15 and without 16. For S, we using the formula P 22,225 and 7 cents multiply 1 plus I 0.0255 to the power of N 16. We substitute out of the amount, and the amount at the end of the investment period is 100,692 and 8 cents. For P, one moment, calculate the value of X. For the I, we using T over M, so 0.0645 over 5 and without 0.01625. Certainly for N, using the MT, so 4 multiply 8 over 6 over 12 and without 4. Next for S, we using the formula S 52,278 and 47 cents to the P multiply to 1 plus I 0.01615 to the power of 34. Substitute the P 52,278 and 47 cents over 1.0166125 to the power of 34. We calculate our orders and the value of X is 30,347 and 31 cents. For question B2 Roman, find the amount of interest charge. To take the interest charge, we using the formula S minus P, so 52,278 and 47 cents minus 30,347 and 31 cents. We value our orders and the amount interest we charge is 21,931 and 16 cents.
For part A, question 2, we need to find how much should Adriana invest today to have enough money for the down payment. Down payment equals to 30 over 100 times 560,000 equals to RM 168,000. To find I, we will use the formula of I equals to K over M. So we got 0.032 over 2 and the answer for I is 0.016. To get N, we will use the formula of N equals MT and we will got 2 times 6 and the answer is 12. To get the P, we will use the formula of S equal to P times 1 plus I to the power of N. Then we got 168,000 equals to P times 1 plus 0.016 to the power of 12. After that, P times 1.016 to the power of 12 equals to 168,000. P equals to 168,000 over 1.016 to the power of 12. And after that, we got the answer that Adriana should invest 138,862.44 cents to have enough money for the down payment. The next question, we need to find how long will it take for the investment of DeMarco to become RM 35,855 and 16 cents. Let's move to the solution. The first step is we will need to find I. To get the I, we will use the formula of I equal to K over M. And we will got 0.0425 over 12. So to get the N, we will use the formula of N equals to MT. And we will got 12T. To find the T, we will use the formula of S equal to P times 1 plus I to the power of N. And we will substitute all that into the formula. So it would take for the investment to become RM 35,855 and 16 cents in 8.5 years.
So for this question, we need to find the number of payment if the amount in the account has accumulated to 9,069 ringgit and 71 cents. For the first step, we need to find the I using the formula I equal K over M. So we got 0.0252 over 12 and we got I equal 0.0021. The next step is we need to calculate the value of N using formula S equal R times 1 plus I to the power of N minus 1 over I. So we get 9,069 ringgit and 71 cents equal 250 times 1 plus 0.0021 to the power of N minus 1 over 0.0021. And the number of payment is 35. So the question of part B, question 1B is we need to find the monthly pension she could receive if she retires at the age of 65 and seeks to draw from the retirement fund until she is 100 years. So to answer the question, we need to find the I. First, using the formula I equal K over M, and we got 0.055 over 12. Also, we need to find the N using formula N equal MT. And we got 12 times 35, and the answer is 420. So to find the monthly pension, we need to use formula A equal R times 1 minus times 1 plus I to the power of negative N over I. So we got 25 millions equal R times 1 minus times 1 plus 0.055 over 12 to the power of negative 420 over 0.055 over 12. So the monthly pension we got is 134,254 ringgit and 7 cents.
Part B, question 2. This question has given the statement about a guy named Bernardan that wants to buy a Lexus MPV that costs RMK, which is why he goes to the bank and took a loan that charges 5.2% of interest compounded monthly and has to pay this loan for over 9 years. So now, let's get through on how to solve this question step by step using the present value formula where A equal R times 1 minus times 1 plus I, the power of negative N per I, where A is the amount we have to find out, R is the periodic payment, 5,560 ringgit and 35 cents, I is the periodic interest rate, which is K per N, where K is nominal rate 0.052 and M is the total number of compounding periods per year, which is 12. So I is 0.052 per 12. T is the loan term in years, which is 9, and lastly, N is the total number of payments. To find N is M times T, so N equal to 108. The next step is we have to substitute the values into the formula and simplify the calculation, where 5,560 ringgit and 25 cents times 1 minus times 1 plus 0.052 per 12 to the power of negative 108 per 0.052 per 12. We have to calculate the amount in the bracket first, so we get the answer of 86.10299916. After that, we have to multiply R with the number in the bracket, so 5,560 ringgit and 25 cents times 86.1029916, and the total amount of K is 47,854 ringgit and 60 cents. Moving forward to the question B. So this question states that Bernardan decided to settle the loan years earlier than the actual maturity date through a single payment. So how much will he pay in the single payment? First of all, the next step is calculate the monthly interest rate. So this gives us I is 0.052 per 12. And the third step is determine the total number of payments. So N is 48 months after 12 times 4. So the final step is substitute the values into the formula and calculate the denominator. So now we have got A equal 5,560 ringgit and 25 cents times 1 minus times 1 plus 0.052 per 12 and the power of negative 48 per 0.052 per 12. We have to calculate the amount in the bracket first, so we get the answer of 43.2525946. So now we have to multiply R, which is 5,560 ringgit and 25 cents, with the amount in the bracket. So we get the amount of A is 240,465 ringgit and 23 cents. And the conclusion is the amount Bernardan have to pay to settle up the loan earlier is 240 ringgit 465 and 23 cents. This calculation illustrates the impact of compounding on recurring payment amount when paying off the loan before the maturity date. So that's the answer to top the questions.